Good morning, students. So, till now, in order to find out the particular integral, we have used the right hand side. One is e power x, and second one is nothing but either sin x or cos x. Now, this is your third form. When the right hand side of your equation looks in the form of x to the power k, where k is nothing but any real number. In that case, how will you find the particular integral? That we will discuss in today's class. If the right side of your equation looking like x power k, so in order to get your particular integral, I just give you the procedure. Later on we enter into the problem. Okay. So see the step-by-step procedure. In the step number 1, represent the given higher order ordinary differential equation in the symbolic form, that is f of d of y is equals to q. So as you all know, q is nothing but your right hand side value of the equation, and d stands for, it is the differential operator, which is nothing but d by dx. So in your d by dx, we have to introduce the capital D symbol in the given equation. So that is the first step. Write the given equation in the symbolic representation. That is f of d of y is equals to q. See the step number 2. Find out the complementary function by calculating the auxiliary equation, which is nothing but f of m is equals to 0. So what is the auxiliary equation here? In your f of d, d is replaced with m. That is the auxiliary equation. So in the d, we have to replace that d with m symbol. So using that auxiliary equation, find out the roots of the equation, and with the help of those roots, you can find the complementary function. So this is the step number 2. Find the complementary function using the auxiliary equation roots. So if you factorize that auxiliary equation, you will get the roots, and using those roots, you can find the complementary function. That is the step number 2. In the step number 3, in order to find out the particular integral, the formula is 1 by f of d of q, and that is equals to 1 by, see here, this f of d we have to represent in terms of 1 plus or minus phi of d. Okay. So this f of d, this denominator, we have to represent in form of 1 plus or minus phi of d, where q is nothing but your right hand side value, which is in the form of x to the power k. So q is x power k, and this denominator function we have to represent. So how will you represent this in the form of 1 plus or minus phi of d? See, remember, in this denominator, in your f of d, we have to choose the lowest term. Choose lowest term of f of d and take that term as a common. We have to take that term outside and write the remaining term. ಯಾರದು ಮ್ಯೂಟ್ ಮಾಡಿ. So take the lowest term in the denominator and take that term as a constant, in the outside. So after that, that remaining factors in this denominator, we have to write in this form, that is 1 plus or minus phi of d form. Okay. Take the lowest term as a common and write the remaining terms in the form of 1 plus or minus phi of d. So while doing the problem, you will get to know how to take the common and how to write the remaining terms. Okay. So this is the step number 3. Find the particular integral, write the formula, and represent the f of d in terms of 1 plus or minus phi of d. Write the right hand side value as a q. So after that, if you take this complete denominator to the numerator side, what it will become? The power of this sign changes of the power. That means if you take this 1 plus or minus phi of d to the numerator, the power become negative. You will get 1 plus or minus phi of d whole power minus 1 into x power k as it is. Okay. So take this to the numerator, we will get 1 plus or minus phi of d whole power minus 1 into x power k. So this is about the step number 3. So after that, we have to expand this one. So in order to expand this one, so I just so see here, this expression which we have taken in the numerator, this expression definitely this is going to use the principle, either it is 1 plus x whole power minus 1 or 1 minus x whole power minus 1. So it will be in the form of either 1 plus x, consider this one as a x term, 1 plus x whole power minus 1 or 1 minus x whole power minus 1. So out of these two forms, you will definitely get one form. So you will definitely get one form out of these two. Okay. So you are converting this f of d in terms of either 1 plus x or 1 minus x. So this is about this expansion, 1 plus or minus phi of d expansion. So suppose if you get 1 plus x power minus 1, then how will you expand this one? We have to expand this one using the binomial theorem. See here, if you get, suppose in your example, if you get 1 plus x whole power minus 1, you have to simplify like 1 minus x plus x square minus x cube plus x power 4 plus and so on. So this is the direct expansion. We have expanded these two using the binomial theorem. So you can just directly remember these two. When you get 1 plus x whole power minus 1, you have to simplify like this. If you get 1 minus x, you have to expand like this. 1 minus x whole power minus 1 is 1 plus x square plus x power 4 plus x power 5 and so on. This is the expansion. So out of these two, you will definitely get one form. Either it may be 1 plus or 1 minus. So according to that, you have to use the simplification. So after that, you are getting the complete solution, that is just the combination of complementary function and the particular integral y is equals to yc plus yp. So this is about the procedure. So you just do the simplification and calculate this particular integral yp, and finally you are getting the complete solution, which is yc plus yp. So this is about the procedure when the right hand side q is equals to x to the power k form. Okay. So in the what we have do in the step number 1, write the given equation in the symbolic form. In the step number 2, find the auxiliary equation, and if you factorize that one, you will get some roots, and with the help of those roots, you can find the complementary function. And after finding that, you have to go to the particular integral, that is use the formula, and in the denominator we have to expand, we have to express in terms of 1 plus or minus phi of d form. If you take this complete denominator to the numerator side, the power becomes negative. The power changes. So positive will become negative x to the power k as it is. So for expansion, if it is in the form of 1 plus x power minus 1, you have to write like 1 minus x plus x square minus x cube plus and so on. Suppose if you get 1 minus x power minus 1, in this form we have to simplify like 1 plus x square plus x cube plus and so on. So after doing the simplification, you are going to the final answer, that is the complete solution. by combining the complementary function and the particular integral, you will get the general solution of the equation. So this is about the procedure. Now let us have a problem. So solve d square y by dx square plus 4y, and that is equals to x square plus 3. So for this higher order ordinary differential equation, the right hand side, is it looking like x to the power k form? Yes, it is in the x power k form. Here where k is nothing but, what is your k value? K is nothing but 2. So for that I am using this third method which is nothing but q is equal to x to the power k form. So before going to that, first you represent this given equation in the symbolic form. So that the symbolic form is nothing but f of d of y is equals to q. Where what is your f of d here? First write the symbolic form, that is d square plus 4 of y is equals to x square plus 3. Here f of d is d square plus 4. And q is nothing but, that is the right hand side value, that is x square plus 3 is your q. And what about the k value? So this is in the form of x power k. So k is 2. Okay. So after getting this symbolic form of the equation, so now you are finding the auxiliary equation. So the procedure is f of m is equals to 0. What is the auxiliary equation procedure? F of m is equals to 0, and that is, what is your f of d? F of d is d square plus 4. So in your d we have to replace with m. It will become m square plus 4 is equals to 0. M square is equals to, if you take this positive 4 to the opposite side, it will become negative. So m is equals to plus or minus under root of minus 4. This one can be written as a plus or minus 2i. So this is our root of the equation, which is the complex root. So what is the procedure of writing this complex root in the form of complementary function? So C1 cos imaginary part is 2, C1 cos 2x plus C2 sin 2x. So in this complex root, there is no real part is there, right? There is no real part in this complex root. So we will write e power 0 into x. E power 0 is 1. So you will get the complementary function is like C1 cos 2x plus C2 sin 2x. So this is about the complementary function. So now after getting that one, you are entering into the particular integral. The procedure is 1 by f of d of q. As you all know, what is f of d here? F of d is d square plus 4. Q is the right hand side value of the equation, that is x square plus 3. So now you can simplify this one as we seen in the procedure. So we have to write this denominator in the form of 1 plus or minus phi of d by taking the least term as a common. So which one is the least term here? Least one is 4. So you can take 4 as a common term, 4 as a outside, and write the remaining terms. Okay. So I told in your procedure that denominator should be converted into 1 plus or minus. In order to take that one, I am just taking 4 as a constant term, and it is the common here. So I am writing the remaining term, that is 1 plus d square by 4. Okay. So I just write here. So in order to find your particular integral, yp is equals to The formula is 1 by f of d of q. So what is your f of d? F of d is d square plus 4 of q is nothing but your right hand side value, that is x square plus 3. So we have to write this denominator in the form of 1 plus or minus form. So take the least one, that is 4 as a constant. Write the remaining terms now. So we can write 1 plus d square by 4 into x square plus 3 I am keeping as it is. So what we have to do now? This denominator, this 1 plus d square by 4, we have to take it to the numerator side. So what you will get? You will get 1 by 4 as it is, and take this complete term to the numerator one, so power becomes negative. Whole to the power minus 1 x square plus 3 as it is. So now if you observe this one, it is in the form of 1 plus x whole power minus 1. So now you can apply that expansion, that binomial expansion. You have to remember that one. What is the expansion? 1 plus x whole power minus 1 is 1 minus x plus x square minus x cube plus x power 4 minus and so on. So this is the binomial expansion. So we have to expand like this. So this is the 1, this is the x. So 1 minus x is d square by 4 plus x square means d square by 4 whole square minus and so on into that right hand side value is x square plus 3. So this is the binomial expansion of your equation. Now you can simply expand this one, 1 by 4 as it is, 1 minus d square by 4 plus it will become d to the power 4 by 4 4 the 16, 16 minus and so on into x square plus 3. So now I will write this expression, this entire expression in the one expression. You just expand this one by removing the brackets. So 1 into x square plus 3 is x square plus 3. So similarly minus as it is 1 by 4 d square into x square plus 3 plus 1 by 16 as it is d to the power 4 into x square plus 3 minus and so on. So I will write in the one expression. So before going to substitute the values, you just roughly calculate. So what do you mean by d here? What is the d stands for? D stands for the differential operator. D is nothing but d by dx, which is the derivative term, right? So what is the derivative of x square here? X square is there, no? What is the derivative? What is the d by dx of x square? It is 2x. Derivative of x square is 2x. Similarly, what is the d square? Second derivative of x square. What is the second derivative of x square is 2, right? Derivative of 2x is 2. This is the second derivative of x square. Same for similarly d cube, that means third order derivative of x square. What is the third order derivative is 0, right? So the first order derivative of x square is 2x. Just you differentiate this one. D stands for the differential operator, which is nothing but d by dx. Derivative of x square is 2x. The second order derivative, that means d square by dx square of x square is 2. Similarly, d cube y by dx square and dx cube. Third order derivative. What is the? This is the constant. So it will become 0. Okay. So that means the third order derivative is 0 means the rest of remaining all the derivatives all are equal to 0. D power 4 is 0, d power 5 is 0 and so on. Okay. If d cube is 0, that means the rest of the remaining derivatives Rest all are equals to 0. So you have to check first. Before substituting the values, you first roughly calculate this one. See here. So that the value I am substituting, this is equals to 1 by 4. I am keeping as it is. It is that x square value, x square plus 3 minus 1 by 4 also I am keeping as it is. So here second order derivative of x square. What is the second order derivative is? D square of x square is 2. Okay. So write here 2. So 3 is the constant. It will, of course, it will become 0. Again 1 by 16 into d to the power 4 of x square. What is the derivative? Fourth order derivative is 0. So here d3, that means the third order derivative is 0, means fourth order is also 0. So write this one as a completely 0. Okay. So see the next step, that is equals to 1 by 4 into x square minus 3 minus 2 by 4 becomes 1 by 2. Bracket close. So that is equals to 1 by 4. You can expand this one. You will get the plus. So this is plus 3, no? So plus 3. 2 3s are 6 minus 1 is plus 5 by 2. So this is our particular integral expansion. So this is our final simplification. This is the answer of your YP, that is particular integral. Therefore you are getting the complete solution, that is y is equals to yc plus yp. So what you got? The complementary function, that is c1 cos 2x plus c2 sin 2x into e power 0x. Of course it will become 1. So plus the particular integral is 1 by 4 into x square plus 5 by 2. So this is your complete expansion, complete simplification, or a complete solution of the given differential equation. So what we have done here, in order to find the particular integral, I just explained the particular integral. Find the formula of that one. So in this denominator, we have to take the least one. So suppose if the 4 is the least one, you have to take 4 as a common, and we have to express this remaining term in this form only. That means 1 plus or minus something phi of d. That means it may be d square or d cube or something. You have to express in this form only. So after that, take this complete denominator to the numerator one. So you will get the power becomes negative, and use the expansion by the binomial theorem, that is you may get 1 plus x whole power minus 1 or 1 minus x whole power minus 1. Using this expansion, you can find the particular integral of the equation and combine those two values. You will get the general solution of the equation. This is about the first example. See the next example. Solve d cube y by dx cube plus 8y, and it is equals to x power 4 plus 2x plus 1. This is the right hand side value, which is the q term. First we have to represent this one using the symbolic representation. So what it will become? It will become d cube plus 8 of y is equals to that right hand q term as it is. That is x power 4 plus 2x plus 1. So after finding this symbolic representation, you can write the equation in the auxiliary form, that is m cube. That means in your f of d, replace with the m, that is, it will become m cube plus 8, and it is always equate with 0. So can I write this 8 as x 2 to the power 3? Of course, 2 power 3 is 8. So I am just writing 8 as a 2 power 3. So if you observe this one, it will be in the form of a cube plus b cube form. So what is the a cube plus b cube formula? A plus b, a square minus ab plus b square. This is the formula, and it is in the form of a cube plus b cube form. So write the terms. What is a plus b here? M plus 2. And the second form, that is second term, is a square minus ab plus b square. A square is m square minus ab is 2m plus b square is 4, and it is equals to 0. So now we will get the first term, first root, that is m plus 2 is equals to 0. Take the positive 2 to the opposite side, it will become negative 2. So our first root is m is equals to minus 2. So in order to find the second and the third root, because it is the third order derivative, d cube means definitely we will get the 3 roots from this equation. So using the quadratic formula, simplify this one, that is minus b becomes positive 2, minus b plus or minus just wait a minute. So plus or minus under root of b square, what will become? It will become 2 square means 4 minus 4ac. 4, a is 1, c is 4. 4 for the 16 divided by 2a. A is 1 divided by 2. And that is equals to 2 plus or minus 4 minus 16 is minus 12 by 2. And it is equals to 2 plus or minus. So minus 2 can be written as a minus 4 into 3. So if you simplify this one, if you remove the roots, or you will get 2 plus or minus 2i under root of 3 divided by 2. So you can cancel this one, 2 ones are 2 ones are, and here this 2 also cancels. So we will get the roots like 1 plus or minus I root 3, which is the complex root. One is the real root, another one is the complex root. So in order to write the complementary function, first write the real roots, that is c1 a to the power of ax, that means minus 2 into x, plus c2, this is the complex root, can be written as a c2 cos imaginary part into x plus c3 sin imaginary part into x into e to the power of real part is 1, that is 1x, e to the power of 1x. So this is about the complementary function. So after finding the complementary function, we will enter into the particular integral. The formula is 1 by f of d of q. So as we know, f of d, what is your f of d? It is dq plus 8, and the q stands for the right hand side value. It is x power 4 plus 2x plus 1. So in this denominator, we have to take 8 as a common. This is the least term. So take 8 as a common. This is the constant term. So we have to express this one in terms of a 1 plus or minus. So of course you will get plus form only. 1 plus dq by 8. So this q term as it is, and that is equals to 1 by 8. Take this complete term to the numerator, so it will become minus 1 whole to the power minus 1. Take this complete term in the numerator side, it will become 1 plus dq by 8 whole to the power minus 1 into x power 4 plus 2x plus 1 as it is. So if you observe this one, it is also in the form of x power 1 plus x whole power minus 1 form. So using that binomial theorem expansion, that is the direct expansion of 1 plus x whole power minus 1. So you have to remember that expansion. What is the 1 plus x whole power minus 1? It is 1 minus x plus x square, alternative signs, minus plus minus x power 3 plus x power 4 minus x power 5 plus x power 6 and so on. So in this form we have to write this expansion, you have to write this terms. So what is x here? X is dq by 8, right? So substitute in this expansion, 1 minus x is dq by 8 plus x square, that means d cube by 8 whole square minus and so on. Okay, so write the in the one expansion. I will write this one in the one expression. So you just remove the brackets and multiply this one 1 by 8 as it is. So 1 into x power 4 plus 2x plus 1 is x power 4 plus 2x plus 1 minus 1 by 8 I am keeping as it is. So this is the d cube into x power 4 plus 2x plus 1 and plus 1 by this is 8 to the power square, and you can write the remaining terms and so on. So if you observe this one, here also d stands for the differential operator. Okay, this is the d by dx. D is nothing but d by dx, that is the derivative of x power 4 and 2x. So what is the derivative of x power 4 here? So that derivative term we have to write here. See, this is the d of, that means derivative of x power 4 plus 2x. What is the first order derivative? It will become 4x power 3 plus 2. So what is the second order derivative? That means d square. D square stands for, it will become 4 3 is 12 and x square, this is the constant term, becomes 0. This is the second order derivative. Okay, so this is the second order derivative. Similarly, what is d cube? This is the third order derivative, stands for 24 into x. Just you apply the derivatives. So what about the d power 4? Fourth order derivative is 24. What is the d power 5? D power 5, this is the constant, so it will completely becomes 0. If d power 5 is 0 means, what about the remaining terms? The rest of all the remaining derivatives, all are equal to 0. D power 6 is 0, d power 7 is 0 and so on. Okay, so this is about the d form, expansion of the derivative. So now you can substitute here. So this is the d cube of x power 4 plus 2x plus 1 is there. So third order derivative of x power 4, it is d cube of x power 4 is 24 into x. So this is 24x. And the third order derivative of 2x, it is becomes completely 0, and this is also constant, so it will also become 0. So in the further expansion, write the 1 by 8 as it is, and in the bracket what are the remaining terms? It is x power 4 plus 2x plus 1 is there. So 8 ones are 8 3s are 24. So it will become only 3x. Remaining term is only 3x. So this 3x and this 2x becomes 5x. So you will get the terms like, so here minus is there, no? Yes, this is the minus 3x and it is plus 2x. So 3 minus 2 is minus 1. So minus x, that is the minus x, and you will get the particular integral 1 by 8 x power 4 minus x plus 1. This is the particular integral of the equation. Now if you combine the complementary function and the particular integral, you will get the general solution of the equation. So this is about the second form. See the example number 3. The given higher order ordinary differential equation, which is in the form of d cube plus 2d square plus t of y is equal to, the right hand side values are e power 2x plus x square plus x. So we have to write this one directly to the auxiliary form because it is in the form of a symbolic representation already. So we directly go to the auxiliary equation, that is m cube plus 2m square plus m is equal to 0. As we know, this is d cube is there, that means you will get the 3 roots. Third order derivative means you will definitely get the 3 roots from this equation. So if you take m as a common here, write the remaining terms, m square plus 2m plus 1 is the remaining, that is equals to 0. And if you find the factors just by expanding m square plus m plus 1 and take the m as a common, remaining is m plus 1. In the last two terms, take plus 1 as a common, remaining is m plus 1. So you will get the roots like m plus 1 and m plus 1. Take it to the opposite side, you will get that complete roots. 1 is 0, so this is the 0, m term is 0 and this is also minus 1 and minus 1. These are the roots of this auxiliary equation which are real but repeated, real and repeating roots. So how will you write the complementary function in case of a real and repeated roots? That is c1 e power 0x. This is about the real root. So in order to write the repeating roots, it is c2 plus c3 into x into e to the power of minus x. This is about the complementary function. So you directly go to the particular integral. So the formula is 1 by f of d of q, where q stands for the right hand side value, that is e power 2x plus x square plus x. So if you observe this one, it is also in the form of e power ax form, that is the first form. If you return the notes, please once turn over and see the procedure of it. How will you solve that expansion e power ax form? Okay, so this is in the form of e power ax, that first method, and plus x square, it is in the form of x power k. This is the third form. Okay, so you just expand this one. So e power 2x divided by dq plus 2d square plus d plus x square plus x divided by dq plus 2d square plus d. So how will you simplify this one when the right hand side is e power x form? What is the procedure of finding this one? You have to write this a complete value, this a value in this complete denominator side. Substitute the a value. What is the a here? A is 2. So 2 cube plus 2 into 2 square plus 2. And in the second term, we have to represent the x power k form in the 1 plus or minus phi of d. So which one is the least term here? Least one is d. So take d as a common. Take d as a outside. Now you can write the remaining terms. So if you take d outside, what are the remaining terms? 1 plus d cube by d plus 2d square divided by d. So here 1d and 1d get cancelled, remaining is d square. So here 2d square is there, here 1d and 1d get cancelled, remaining is only 2d. So now it is looks like 1 plus phi of d. So now you have to take this complete denominator in the numerator side. So the power becomes negative. You will get 1 plus d square plus 2d whole to the power minus 1, x square plus x I am keeping as it is. So that is equals to e power 2x by 18. E power 2x by 18 plus 1 by d. So this is also looks in the form of 1 plus x whole to the power minus 1 form. So using that binomial expansion, you directly simplify this one. So what is that expansion? 1 minus x plus x square. So here 1 minus x is this complete term. X is d square plus 2d plus x square. You can write this term also. Plus and so on into e to the power of x square plus x. Okay. So I will write in one expression, just removing the brackets. So 1 into x square plus x is x square plus x. So here, before substituting that value, you first roughly calculate this one. So what is the derivative, first order derivative of x square plus x? D is the d by dx. Derivative of x square is 2x plus 1. Right? So what is the d square? Similarly, what is the d square by dx square? Second order derivative of x square plus x is 2. This is the 2 only. So if it is the constant, means all the remaining rest of the derivatives all are completely become 0. That means d cube, third order derivative is 0, fourth order derivative is 0, and so on. So this is about the d square, that means the second order derivative. So what is the derivative of second order derivative of x square plus x? So second order derivative is only 2 here. So write 2 as it is. So minus, this is the 2d. So if you keep 2 as it is, what is the derivative of x square plus x? This is 2x plus 1, right? This is, I am keeping 2 as it is. So derivative of x square plus x is 2x, x square is 2x, x is 1. So 2 to the 4x. So this is minus is there, minus 2 into 1 is 2. So that is equals to e power 2x by 18. Now you can solve this one. 1 by d as it is, x square. So this is minus 4x and plus x is minus 3x. So minus 2 plus 4. See here, remember this one. So I just give you, if d stands for the differential operator, right? D is nothing but d by dx. Then what do you think about the 1 by d? What do you mean by 1 by d? If d is differential operator, that means d by dx, then what about the 1 by d? 1 by d stands for the reverse of the differential operator. D is the differential operator, means 1 by d is reverse of the differential operator. Reverse means it is nothing but the integration. Inverse of the differentiation is integration. You please remember this one. So 1 by d stands for the reverse of the differentiation. If d is the differentiation, that means 1 by d is the reverse of the differentiation. Reverse of differentiation is integration. Integration of the x square minus 3x minus 4 of dx. Okay. So 1 by, this is, it is equals to e power 2x by 18 plus integration 1 by d means integration, that is the reverse of 1 by d. Reverse of the differentiation. Integration of x square minus 3x minus 4 into dx. Now we can integrate this one. So this first term I am keeping as it is, plus x square means x cube by 3 minus 3x can be written as 3x, it will become x square by 2 minus 4 into dx is 4x. So this is about your particular integral. And combine these two, that complementary function and the particular integral, you will get the general solution of the equation. Okay. So with this, the problems related to x power k form, when the right side is x power k of your higher order ordinary